Hi, my name is Maria Jose Lozan, and this is a video for the video assignment 4 for Math 2000. So the problem is, let r be larger than 0 or smaller than big R. Find the volume of the torus generated by revolving the disk of radius r, centered at the point big R, 0 about the y-axis. So in order to find the volume, we need to take the integral from negative r to r of the function, and in this case it would be r squared minus little r squared, and usually the pi would be inside, but as it is a constant value, I have put it outside the integral to make things easier. So as we are revolving this about the y-axis, little r becomes big R minus square root of r squared minus y squared, and big R becomes r plus square root of r squared minus y squared. So we replace this here, so we have a pi integral of from negative r to r of r big R plus square root of r squared minus y squared all to the power of 2 minus big R minus square root of r squared minus y squared all to the power of 2 dy. And when we expand this, we're left with r squared plus 2r square root of r squared minus y squared plus r squared minus y squared. The same here, except that here we have a negative sign because of this negative. And as you can see, we have like values, so we have the r squared, the little r squared minus y, and we cancel them. So we're left with pi integral of negative r to r of 4r square root of r squared minus y squared dy. And as this is a constant value, we can put it outside the integral to make things easier. So we are left with negative 4r pi integral of negative r to r from square root of r squared minus y squared dy. And in order to be able to integrate this, we have to separate the values inside the square root into r squared. 1 minus y over r all to the power of 2, and this is equal to this, but we changed it in order to do the trigonometric functions. So as we have the r squared here, we can take it out, the integral sign, the square root sign. So we're left with 4r pi r integral of negative r to r. And as we have in order to do trigonometric substitution, we use the triangle to find the values we need to replace. So sine of theta is y over r, so y equals r sine theta, and the derivative of this would be arc cosine of theta d theta, and theta would be arc sine y over r. So we replace this here, so we're left with 1 minus sine squared of theta times arc cosine of theta d theta, as dy is arc cosine of theta d theta. So now we have 4 big R pi little r squared. As we multiply this r to the outside, as it is a constant value, from the integral from negative r to r, and as this is equal to cosine of theta, and this is cosine of theta as well, when we multiply this, we are left with cosine squared of theta d theta. And now, in order to make things easier, we can replace this with 1 plus cosine 2 theta over 2, as it is a trigonometric function. And so we can cancel this 2 and this 4, and we're left with 2 big R pi r squared integral from negative r to r of 1 plus cosine of 2 theta d theta. And so now in order we can integrate this, so we're left with 2 big R pi r squared brackets theta, as the integral of 1 is theta, plus sine of 2 theta over 2 from negative r to r. And we know that sine of 2 theta is equal to 2 sine of theta cosine of theta, and we can replace this here, and so we're left with sine of theta cosine of theta, as this 2 cancels with this 2. And now we're left with and we can replace the value of theta as well as these values now in order to be able to solve for y. And so we have 2r pi r squared of arc sine y over 3, as we had it here, plus y over r, as sine of theta is y over r, times cosine of theta, and so according to the triangle, it's square root of r squared minus y squared over r from negative r to r. And so when we replace both our values, we're left with 2 pi big R little r squared of brackets arc sine of r over r plus r over r times 0, so this would be 0, minus arc sine of negative r over r plus negative r over times 0, which would also be 0. So we're left with 2 pi big R little r squared times arc sine of r over r minus arc sine r over r, as this negative would go to the front and this would become addition. So arc sine of r over r, which is equal to 1, and arc sine of r of r is 1, so arc sine of 1 is pi halves. So we're left with 2 pi big R little r squared of pi squared plus pi over 2 plus pi over 2 equals to 2 pi big R little r squared of pi, as this becomes pi, which when we multiply them together we have 2 pi squared big R little r squared equals pi r squared 2 pi r. So this is the final answer.